what's up? I'm Jesse. Welcome back to the Wolfram Tech Conference 2018. If you weren't here before, I've just been talking to developers and other interesting people who are using Wolfram technology in very cool ways, and I'm sitting here with Riccardo. Could you tell us a little bit about yourself, what you do at Wolfram, and what your focus is on?
I'm from Italy. Yeah. And I work from home, I work remotely, which is a great thing about this company. It allows you to work remotely. I actually started working after the Wolfram Summer School, which is basically a school that we are doing in the summer where people can come and learn about Wolfram language. And yeah, since then I've been working for like 5 years now. So yeah.
Cool. So what do you do? Like, what team are you on? And what do you focus on?
I'm on a small team. Since I started working principally in data validation with interpreter for function. My background is I'm a web developer, and so I've been focused on web technology. And right now I've been working on database integration. And what we will show here, I think, is something that branch out from the database integration project, because we were using Python internally, and we figured out that there was a core of what we were doing that was interesting for other people, and so we decided to branch it out and make it like an independent project. Yeah.
Cool. So what exactly what are the current ways that Wolfram language can interact with Python right now?
Well, since version, I think it was 11.2, I guess, we started external evaluate. That is like a generic framework to interact with other languages. We currently support, I think, Java, Python, and JavaScript, and probably also the Chrome extension. And this was done via a Python link that is sending messages through basically the notebook to Python and sending back messages again as the Python response. And since then we started improving the way this messaging was working, and we created a library that allows you to interact with Python, either like to this library in particular is the other way around, is to start a kernel from Python, or to create Wolfram language code directly from Python, or to read Wolfram language code directly from Python, which is something new that we are planning to release very soon on GitHub as an open source project.
So in effect, the Wolfram language is an external library for Python, like any other sort of library that a Python user would.
What did you say, sorry?
So the Wolfram language itself is basically like a library in this case, just like any other library you bring in.
Yeah,
Okay.
exactly.
Cool. So how does this sort of library? What are some common applications you see with this? Like, what is a common workflow for using the Wolfram Client Library?
Well, this library is, for example, there are a lot of amazing library for Python. I think a lot of Python developers know that there is a whole ecosystem of enthusiastic developers that are developing a lot of very nice library that goes from web development to machine learning to everything like that. And sometimes you are producing a lot of data within those library. One example is NumPy that that is used in data science, which is a very fast library that allows you to do operation directly on C arrays, and we support basically the serialization of all those arrays directly into Wolfram language 12.2 row array. They're called now. They were called numeric array. I think no, now they're called numeric array. Yes. And basically you can serialize all your data as numeric array in WXF format, which is a format that we implemented in 11.3. And then you can import back all this data from Mathematica and continue from there. This is an example workflow. Or you can extract data from Wolfram language, export it as WXF, import it back in Python, do some analysis, export and back, and continue for Wolfram language. There are all kinds of possibilities that you can do with the library. You can start a kernel within Python. You can start a pool of kernel from Python, and parallelize basically your computation of 4 or 5 kernels in a pool, and do them in parallel. Yeah, so those are a couple of examples of things you can do. The library is going to be available very soon, I think.
Yeah, can you show me a little bit
Yeah,
of
sure.
this
This is
documentation?
this is a preview. I mean, this is the documentation that we're planning to show. For example, you see that it's gonna be on pip, so it's gonna be like very easy to install. You just do pip install Wolfram Client, and you can do basically there are tools to do evaluation directly with the same API, either on your local machine. You see that you just need to insert the path of your local Python installation. So I don't know, like on OS X it's gonna be /application, Mathematica, kernel, whatever. You start the session, and then you can use this syntax, which is very nice in Python, that allows you to create Wolfram language code directly using this factory. There is a dynamic object in Python, and then you can just evaluate in the kernel and get back the result as a Python object. And there are APIs. Basically, the API is the same whatever you are interacting with your local kernel or with a cloud kernel. So you can either spawn, I don't know, like 10 kernels directly on the cloud, or you can spawn kernels on your machine. So the API is going to do the same. So you can start by developing things locally, and then move to the cloud when you are on production, or the other way around. So this library allows you to abstract the interaction with the kernel very easily, and to only focus basically on the computation and things that you need to do. Which I think is a very nice interface, because compared to other languages, Python allows you to have a very nice syntax. It's something that you cannot really have in due to this dynamic nature. You cannot really do the same in Java or in JavaScript. It's something that is just, I think, impossible. But with this syntax, basically, you can create expressions, and you see here you can mix like expressions that are either like verbatim, so from a string, or by using those constructors that Python allows you to do. So this is actually now a Python object that you construct, and you can construct any kind of arbitrary expression with this syntax. It's very nice. I've been using it a lot, and it really works great. The other thing that you can do here is that you can have the same system is used in notebooks, and you can just start Python cells. Hopefully, it will start. Oh, Python cells are something new in the notebooks, and allows you to create. I think it's
Should be a
command.
to get a Python cell.
Yeah.
I think it should be shift. It's a caret, right?
This guy? Oh yeah.
Yeah.
That was so. And so this is just a computation. It's running by using external evaluate, and it's using the very same library. Internally, we're using this library to convert Wolfram expression to Python and to read them back, and we are open sourcing the library that we are internally using, so that people can also use it and can manually, from within Python, create expressions and then communicate back with the kernel and so on. Yeah, so we have been using this syntax. It's really nice.
Yeah.
And the other thing that you can do here is to use the low-level serialization. That should be. So yeah. There are functions to serialize and deserialize, and there is a single API that you can use. and basically the same functions allow you to serialize both in the input form, which is human readable, but then by just changing the format, you can now produce WXF, which is a binary representation of the Wolfram language, and is way faster and more compact, and it's more like to communicate from machine to machine. And you just need to change, you see, one line of code, and then you are serializing using another format.
Cool.
Yeah.
Can you talk a little bit more about the interaction between the Wolfram Client Library and the Wolfram Cloud? Sort of how does the cloud fit into like sort of a user workflow for this sort of thing?
Yeah, for now, exactly. So for now, the cloud can be used to basically spawn kernels. And so let's say that you need to do like a very long computation or something that needs to be parallelized. Then what you can do is that from your machine you describe the core operation and the data collection. Then you basically use some kind of map reduce method where basically you are just mapping those expressions to several kernels, and on the cloud you can spawn how many kernels you want, and basically parallelize your computation. I don't know, like use 20 kernels in parallel, 30, and reduce the time of the computation and get back an aggregated result, and then you can continue working on Python or yeah. So for now, yes, the Python the is not really allowed for security reason right now to run arbitrary code on the cloud platform. So you cannot really run directly a Python interpreter on the cloud. But from Python on your local machine, even like on a virtual machine or WS or DigitalOcean or whatever, you can communicate to the Wolfram cloud. If you are having a private cloud or something, you can install, of course, Python and then use it there. But for the moment, the cloud you need to interact with externally, and yeah, and you can basically start a kernel pool and to parallelize your operations.
Cool. This is really cool. It seems like a huge sort of step in sort of bridging this kind of like gap between Python users and would-be Wolfram language users. Where do you see this library or any sort of external connections to Python? Like, where do you see this going in the next couple of years as far as development?
I hope people will get excited by that, and we actually want to get back opinions from the community. Obviously, we want to know, how people are using this thing. If it's getting useful, we want to have like feedback from people, features requests. For now, we are maintaining this library, and we really want to optimize the performance. I mean, like from I don't have the numbers right now, but I think like we did a huge performance improvement by using this code from 11.2 to 12, which is at least 100% faster. But again, I don't have the exact numbers, and the library can be optimized even further because we can add C extensions. And so like the serializer and the deserializer can be even faster. For now, the performance is great because NumPy arrays are directly taking the C representation and they are pushing to the WXF serialization. But again, I hope that we can have suggestion and maybe even pull requests from other people. Right now we are supporting only NumPy, but I guess there are a lot of other frameworks, like I can think about Panda and other things that we want to support. So
this is going to be on GitHub for anyone to sort of contribute to. Cool. Awesome. Do you have anything else you wanna talk about related to Python Client Library?
No, not really. I mean, the library, there is a whole documentation here. We are the nice thing here is that we are natively supporting a lot of all built-in data types from Python, starting from integer, floating point, decimal precision, and everything that is related to built-in dates. So date object, time delta are translated into quantities. and fractions as well are also translated into rational. So we have like support for all built-in types, and for some external library we think they are useful, like NumPy. And yeah, no, I'm really excited about this project because I'm a Python developer, I'm a Python enthusiast. So I think it's gonna, uh, people are gonna love it, I think.
Yeah, yeah. Well, cool. Thanks for talking with me.
Okay.
And thanks for hanging out with us today.
Okay.
Cool.